It is great my pleasure to presentation this topic in the conference. My topic is about fatigue behavior of thick felt joints made by structures still under different post-welding structure treatments. Come from the Suzhou University of Technology. Uh, Firstly, I would like to acknowledge the support of the funding of fundamental agency and industry partners. This presentation is in divided four parts. The first one is about the motivation of my investigation. As we all know, the one of the in China, there are some the engineering structures industry for the uh, fundamental constructions. So, especially for the mining constructors, such as the mining tube trucks, mining excavators, or crushing screen machineries, for this equipment or machines, it has some special characteristics, such as the particular rate and the high efficiency or high weight. Then it need we to mediate using different or complex word processing, um, using using different materials such as the high strength steel or uh, or structure steel. Um, then in this structure, then there are some different types of welded joint, and finally, informs a different welding structures with different structure size, and uh, induce some the material heterogeneity in harsh surface condition. And for these structures, how about the fatigue properties? And it will if it will if influence the design of the world structures in the service conditions. In the mining check from equipment, there are some the mining check frame structures or is water bomb or is water arm. For this world structure, there are some problems. How about the post-welding treatment mm, uh, for these welding structures, especially for the fatigue strengths? How about the difference between different post-weld difference of fatigue strengths under different treatments? Uh, it uh, it will lead to the about the production of the structures and the efficiency and the cost. So for the solution for these structures, we can from two different ways to solve the problem. Just using the just to use different design strategy to map the structures, or using the computational approaches to design the structures. So this study aims to investigating the fatigue behavior for the felt welded joint, and the post-welding treatment effect on the fatigue strength of felt welded joint. Maybe in the future, it exists some possible application of this study. The first one is about to improving uh, fatigue reliability of the thick welded joint or welded joint, and the second application is to quantity the fatigue strength for different post-welding treatment uh, for the structure components. So we used six different post-treatment five post-treatment to investigate the fatigue property. The first one is the green treatment. The second is about the post-welding head treatment. And the third is about the HFMI treatments. And in the industry, the TIG dressing is common uh, to uh, decrease uh, the defects of the welded joints or welded structures. The last one is the molding. So, in our study, and we used different specimen to investigate uh, the property. Just the single bending specimen and the um, cruciform welded joint. So firstly, we just using the blue line to scanning technology to get the geometry of the welded joint, and then we can obtain the local notch crack characteristics from the local notches. Then we use these parameters to analyze the local stress or using different fatigue assessment or approaches to investigate the fatigue property um, or the fatigue reliability assessment. So for the the test of the single T and the cruciform joint, we use the Q355 B structure steel, and the specimen thickness is about uh, 25 millimeter under the loading, the bending or tension uh, cyclic loadings. So uh, after this fatigue test, we get before the fatigue test, we first get the local notch characters by the blue scanning technology. So we can get different the statistics results for different geometry logos. As in the last pictures, we can see that the radius of the welded tool uh, is largest for the grinding postament, and for the welding, for the as weld statement welded joint owns the lowest the lowest uh, the notch radius. So we can get the fatigue test result after the fatigue test. So we can see that the as well is the uh, is the lowest uh, point under different stress amplitudes. And we can find that the PHWT and the modeling processing are beneficial for the fatigue strength improvement for T joint on the bending loading. And then we fit in the different fatigue data and combining them in the single picture. We can see that the PHWT and the modeling is the best post treatment for the T joint. Then we did the fatigue tests for cruciform worded joint under cyclic tension loadings. And from this result, we can see that uh, the grinding and the tick dressing progressing are beneficial for the fatigue strength improvement of cruciform joint under cyclic tension loading. As we can see from the right pictures, we can see for the tick dressing worded joint, it crack initiate from the worded joint, and for the marling uh, or the grinding uh, cruciform worded joint, it crack near the base metal. So, but it should be noted that for the HFMI treatment, it failure from um, mm, the point of HFMI treatment. So we can summary the result for the tick tracing for the cruciform worded joint. We can get the tick tracing and the grinding and no matter with no failure or with no or with failure, we can see that the fatigue strength uh, will be the best way to improve the fatigue strength for the cruciform worded joint. Then we can get the conclusions. The thick plane RCWG made by Q355D structure steel and different post-weight treatment were studied by the fatigue experiments, and the fatigue and the corresponding experimental SN curves and the fatigue strength for this joint were estimates using the fatigue test data. Second is using the T welded joint under bending loading. Mining processing has a beneficial effect on improving fatigue strength due to the geometry optimization and the water tool. The third is about the cruciform water joint. The tension loading, the T-grace, and the grinding processing has a beneficial effect on improving fatigue strength. Um, and I want to notice that mm, this result just the fatigue test data, and the next step we should to analysis the fatigue reliability under different fatigue approaches, considering the worded tool and the scatter of the worded uh, notch radius. So I just want to show the my presentation here. Thank you for your attention.